All right, good morning, everyone. I hope everyone had a great weekend. Today we are going to look at graphing quadratic equations. I want to let you know some important information first. We are going to have a test on Wednesday of next week, and I will be available after school on Thursday of this week. I'll be out Monday, Tuesday, Wednesday. From Friday of last week, we looked at properties of quadratic functions, and you should have this answered. If you don't, please take a second. You can pause the video to take out your learning goals. I want to make sure you have this answered. The important properties of a quadratic function. You should realize that there is one turning point or vertex, and it's either a maximum or a minimum depending on if your graph opens up or down. It's symmetric, meaning you can fold it in half. Okay, and we like to be able to identify, just like we did with lines, the x and y intercepts. Okay, so today on your notes, you're going to follow along with me as we go through graphing quadratic equations. Again, what we're going to be looking at is how does it look and how do you actually graph them. So, a quick picture. I want to go through what a quadratic equation entails and what the graph actually looks like. So, a couple things. The y-intercept, again, the coordinates, if you're asked for coordinates, you need those xy coordinates of this one is 0, -3. Often there are two x-intercepts. That's where it crosses your x-axis. So notice it's labeled here. For this, the coordinates here are 3, 0. And for the other one, it's -1, 0. You should also be able to see that the axis of symmetry is that dotted line right there, this line of symmetry. And the equation for that is x equals whatever number it's crossing the x-axis at, which right here it's number 1. So x equals 1 is our equation. Notice the equal to sign in it. Okay. And the vertex is the last thing I want to label. If you notice that, the vertex is also called the turning point. And if you want the coordinates of that, for this one it's 1, -4. So important aspects of the graph. You should notice that axis of symmetry, it's where you can fold the graph in half. So it's symmetric on either side. The vertex is also called the turning point or a maximum or minimum. In our graph up here, minimum, that is a minimum. So maybe we can put it here because it's the lowest point on the graph. And the x and y intercepts, it's where the graph crosses the x and y axes. We did this with lines, okay, and we're doing it again with quadratics. We'll do it with lots of different graphs. Okay. Important aspects of the equation. So we looked at this a little bit on Friday of last week. The general form is y equals ax squared plus bx plus c. Remember, to make it a quadratic, you need to have that x squared. The a, b, and c are just numbers. They're usually integers, whole numbers. They're just numbers. So if you notice the c, the number by itself, the c is still just the y-intercept, just like it was in lines. Okay, just like it was in lines. What we're going to be doing a lot of when graphing these is looking for the equation of the axis of symmetry. Equation means you need an equal to sign. Okay, this is something that you are given on all your tests. You're given on the formula sheet, and what I want you to notice is on the formula sheet, it's telling you the equation for the axis of symmetry. It's saying you need the quadratic formula in this form, and the numbers you're going to be looking at are the a. So the a is the number in front of the x squared, the coefficient, and the b, which is the number in front, or the coefficient, of the x. Okay, and the equation is -b/2a. Okay, so if you flip your notes over, we're going to actually do one example together. So the example we're going to look at is graphing a parabola. This is our parabola, y equals ax squared, or sorry, excuse me, y equals x squared minus 2x minus 3. So the a is the number in front of the x squared, so the a here equals 1. The b, the number in front of the x, is this -2. And the c, the number by itself, is -3. I like to identify that before I start anything. So steps for graphing a parabola. Prepare a chart. I have made this already for you, this XY chart here. Okay, so we did that. Find the axis of symmetry. So using the equation x equals negative b over 2a. So over here I'm going to say, okay, x equals negative b over 2a. I'm going to say, okay, x equals negative, and then my b is a -2. Be careful with your negatives, over 2 times 1. So in my calculator, if I do this, I can see, okay, it's on, -2, oops, it's a -2, negative, -2, and then divided by, and we know 2 times 1 is just 2, divided by 2, we get x equals 1. That's our axis of symmetry. That's our equation there. So now we go back to our notes. Choose 3 or 4 values before the axis of symmetry and after the axis of symmetry. So what I do with this x equals 1 is I put it right in the middle of my x values. And then I pick a few values after it and a few values before it. Okay. After that, what I do is I go to my calculator to fill in, use my calculator to fill in the table. Some of you are already very comfortable with this. So in my calculator, I'm going to go to y equals, and I'm going to type in on my calculator the exact equation. So it was x squared minus 2x minus 3. And then I'm going to hit second, it's right over here, graph to get the table of values. And I'm going to scroll to fill in the values that I want. So I see over here at -1, we're at 0. I'm just going to fill in those values. So I have at -1, the graph is at 0. At 0, it's at -3. At 1, it's at -4. At 2, it's at -3. At 3, it's at 0. Okay, and then graph the parabola using those points. So we're going to use those points. So we're at -1, 0, meaning, oops, it's a little off. -1, 0. Then the next point is 0, -3. The next point is 1, -4. My graph is a little bit off. The next one is 2, -3. So you're graphing each of these, and the next one is 3, 0. And then what you're going to do is best you can, you're going to try to, and my board is a little bit off, but create a smooth, there should not be a point. Okay, and some questions we can answer similar to what we did last week is what is the equation of the axis of symmetry? So equation means you need an equal to, and the equation was x equals 1. We found that out from up here. Identify the coordinates, so I know it needs to be like this, of the vertex. So the vertex is that turning point right here. So that was over 1 down 4, so 1, -4. Determine the coordinates of both the x-intercepts. So there's 2 x-intercepts here, one here and one here. So the coordinates of the first one are -1, 0, and the second one is 3, 0. The coordinates of the y-intercept, there's just one. Y-intercept is just that one, and that is 0, -3. So these are the types of questions that we answered on Friday. Okay, so before you start your classwork, you should be able to answer our learning goals. So take out your sheet, please. We already answered one. How do we graph a quadratic? So you should be thinking of the steps. So the first step is make a chart. The second step is determine the equation of the axis of symmetry, and that's on your formula page. Again, if you want to remember it, it's x equals -b over 2a. Okay, and then in your chart, you fill this in your chart by picking a few values before and after. Okay, and then your last step is graph all those points. Make sure you have axes labeled and draw a smooth curve. So right now what I would like you to do is you can go back to this video at any time if you need to, but what I want you to do is complete your classwork. And make sure you follow our steps. You can leave this frozen up on the board if you'd like, so you can see all the steps that you need to do. Thank you, and I'll talk to you guys tomorrow.